Welcome to the third part of topology. In the last video, we learned about open epsilon neighborhoods, and openness. Now we will use those terms to find an equivalent definition of continuity, which with a bit more abstraction of the terms neighborhoods and openness will no longer require metrical spaces at the base of our definition. But to show that these definitions are equivalent, we first have to look at a lemma. 1.8 lemma. Let f be a function between metrical spaces. Then the following is equivalent. First, f is continuous in x0. Second, for all open epsilon neighborhoods around f of x0 exists an open delta neighborhood around x0, so that f of the open delta neighborhood of x0 is a subset of the open epsilon neighborhood of f of x0. And third, for all open epsilon neighborhoods around f of x0 exists an open delta neighborhood around x0, so that the open delta neighborhood around x0 is a subset of the pre-image of the open epsilon neighborhood around f of x0. And with that out of the way, let's look at our theorem. 1.9 theorem. Let f from x to y be a continuous function between metrical spaces. F is continuous in x0 if and only if, for all u subset of y, neighborhood of f of x0, the pre-image of u is a neighborhood of x0. Or to put it simply, for continuous functions, the pre-images of neighborhoods of f of x0 are neighborhoods of x0. To prove this, let's start with the forward direction. Let f be a continuous and u, subset of y, be a neighborhood of f of x0. Then there exists an epsilon greater than 0, so that the open epsilon neighborhood around f of x0 is subset of u, because u is a neighborhood of f of x0. But then, according to our lemma, there exists a delta greater than 0, so that the open delta neighborhood around x0 is a subset of the pre-image of the open epsilon neighborhood of x0, which is a subset of the pre-image of u. And then, because the subset relation is transitive, the open delta neighborhood of x0 is a subset of the pre-image of u. But that means that the pre-image of u is a neighborhood of x0, which is exactly what we wanted to show for the forward direction. And then for the backwards direction, we look at an arbitrary epsilon neighborhood around f of x0. Of course, this epsilon neighborhood of f of x0 is also a neighborhood of f of x0. Now we use our assumption, because if the open epsilon neighborhood around f of x0 is a neighborhood of f of x0, then the pre-image of the open epsilon neighborhood of f of x0 is a neighborhood of x0. That means that there exists a delta greater than 0, so that the open delta neighborhood around x0 is a subset of the pre-image of the open epsilon neighborhood around f of x0. And if we look at our lemma again, part 3 says that this is exactly equivalent to f is continuous in x0. And we are done with the backwards direction. And with proving that theorem, we are finished with our first chapter. In the next video, we will continue with 2.0 topological spaces.